Hello, grade 7, 8. I'm going to try recording this video again with the volume on this time so that you can hear me talk as we go through today's lesson. Today we're going to look at rotations. In most cases, the rotations are going to be about something called the origin. The origin is 0, 0 on a Cartesian coordinate system. But especially in grade 7, there will be a few rotations today that will be rotated about another point that's somewhere on the Cartesian coordinate system, and we'll look at one of those examples as well. So here we go. Let's get started. Our first example that we're going to look at together says rotate parallelogram DEFG 90 degrees clockwise. So one of the things that they mention in this lesson is that you could use a protractor, which measures degrees, to show you where 90 degrees clockwise would be. And that's what they've done with this dotted line here. They've shown where 90 degrees would be from D to D prime. If we look at that coordinate, though, if we look at all of the coordinates, if we're going to rotate 90 degrees clockwise, they're all in quadrant 1 to start. That means they all have to end up in quadrant 4 down here when we're finished. And that requires the x values and y values. All the x values would have to be positive, and the y values would have to be negative. So if we look for a pattern, D was 1, 4, and D prime becomes 4, negative 1 right there. And we notice something, that the numbers are actually the same. They just got switched, and the y value became the opposite integer. It became a negative number instead of a positive one. So we look at the other values and see if that pattern holds up. E was 4, 4, and it rotates down to 4, negative 4. The same pattern holds. F was 6, 2, and it rotates 90 degrees clockwise down to 2, negative 6. So again, the numbers switched and the y value becomes the opposite integer. G went from 3, 2 to 2, negative 3. So again, that same pattern holds up, that the numbers switch and the y values change to the opposite integer. Let's look at this question here. Here we have plot A, B, C, and D, and I've done that already over here. A, B, C, and D. Okay, and it says, what is the shape? Well, this shape is an isosceles trapezoid. It says, I'm going to change this up a little bit. We're going to rotate the shape 90 degrees counterclockwise about the origin and see if there's still a pattern there, and the pattern might be a little different. So we're going to look at what are the new coordinates. So that means this pre-image is going to rotate 90 degrees counterclockwise, that it's now going to end up, all the coordinates were in quadrant 1. They're now going to all end up in quadrant 2. So as I find the new coordinates, I notice that A changes to A prime of negative 2, positive 1. So again, the numbers got switched, but this time, because it's a 90 degrees counterclockwise rotation, the x value ends up being the opposite integer, and the y value stays the same integer. We've just flipped them. B prime goes from 2, 4 to negative 4, 2. C goes from 4, 4 to negative 4, 4. And D goes from 5, 2 to negative 2, 5. So that are all these coordinates. That is a rotation of 90 degrees counterclockwise. Now, underneath here, it says rotate the image another 90 degrees clockwise about the origin. What are the new coordinates? So that means we're going to end up down here, and we're going to use double primes to show this. This is the same as doing a 180 degree rotation, either clockwise or counterclockwise, from our original A, B, C, D. So let's see if we can find some patterns there. So again, we can, to find the coordinates, we can go from here to here and use the same pattern. Flip the numbers, and the x value becomes the opposite integer. So now it's going to change to negative 1, negative 2 for A double prime, negative 2, negative 4 for B double prime, negative 4, negative 4 for C double prime, and negative 5, negative 2 for D double prime. Well, if we look at the original coordinates compared to the double prime coordinates, we notice there's a pattern for 180 degrees rotations, that the numbers actually stay exactly the same. So A was 1, 2, A double prime was -1, -2. The numbers are the exact same numbers, but the integers become opposites. So instead of the numbers being all positive, they're all now negative. If the numbers were all negative, they would become all positive. Okay, but in this case, we went from quadrant 1 all the way to quadrant 3. That's a 180-degree clockwise or counterclockwise rotation. It doesn't matter which direction you go, because 180 degrees is just halfway around. So we noticed a few patterns there, which we already talked about. Okay? All right. So let's look down here. There's one more example here. This is more of a grade 7 question. We've got the original coordinates A, B, C, and D, and they make a trapezoid again. And we're going to rotate this image about point R, which is right there. It's kind of in the middle of the shape. Okay, so the easiest way to do the 180-degree rotation is to count how many spaces across and how many spaces up and down each point is from R, and then do the opposite to rotate it 180 degrees. So if I start with A, it is 1 space left and 1 space up from R. So it's going to rotate 1 space right and 1 space down to be A prime. B was 1 space right and 1 space up from R. So it's now going to be 1 space left and 1 space down from R. C is 5 spaces to the right and 2 spaces down from R. So it's going to now go 5 spaces to the left and 2 spaces up. We just keep doing the opposite. D was 3 spaces to the left and 2 spaces down from R. So it's going to now be 3 spaces to the right and 2 spaces up. And when we connect the dots, it makes the same trapezoid, except it's been turned upside down. And that's what rotations are. They're a type of turn. So we have rotated this 180 degrees about point R, which makes the trapezoid look like it's been turned upside down. So there are some practice questions there for you to work on today. These are due tomorrow morning. Please make sure you connect with your meeting again with your math teacher so that they can help you with questions. And good luck.